In this video, I'm going to explain the difference between categorical cross entropy and sparse categorical cross entropy. So when I started deep learning, particularly multi-class classification, this was a very confusing concept for me. When to use categorical cross entropy loss and when to use sparse categorical cross entropy loss functions. So in this video, I will explain the difference when you should use each of them, and I will show you an example in TensorFlow Keras so that clears your concept. So you should use categorical cross entropy when your output labels are one hot encoded labels. So you have a multi-class classification problem where you have to where you have more than two classes in the output and you have to choose one of them. In that case, if your output classes are like this or your output labels are like this, so for instance you have 4 output classes, you will have 4 columns in the output, and in each column you will see binary values. So for this record, for instance, the output here for the first row will be good, the output here for the first row will be for the second row will be very good, and so on. So if you have output like this, you will use categorical cross entropy. On the other hand, if your output in the case of multi-class classification looks like this, it is in the form of integers where the output of the first row is 1, the output of the second row is class 3, and the output of the third row is class 2. In this case, you will use sparse categorical cross entropy. So this is the main difference. If normally sparse categorical cross entropy and categorical cross entropy functions, both of them are used for multi-class classification. But in case if you have output labels like this, so your multiple classes in the outputs are arranged like this, where each class is a column having binary values or one hot encoded values, you will use categorical cross entropy. Else, in this case, if your output looks like this, you will use sparse categorical cross entropy. So I have written an article on this concept, which I will link in the description of this video, and you can go to this article and check in detail the difference. In this video, now I will show you the difference between sparse categorical cross entropy and categorical cross entropy with the help of TensorFlow Keras example. So I will import some libraries here. You can see here, you can just copy and paste this from my article. So this is Google Colab, so you will not have to install anything. You will just have to press Shift and Enter, and it will install all these libraries here. So we will use this sample dataset in this tutorial. I have written the code here which imports this dataset, the CSV file of this dataset, into my application here. So you can simply click here and upload the downloaded CSV file from Kaggle. So you'll have to download the file from here, and then you go to your Google Colab, this arrow, and here you can upload your file. So I have uploaded the file. Next, I will read this dataset into a CSV file, and I will give these column names to this file and press Shift and Enter here. So you can see this is our dataset. We have 7 columns. Basically, the dataset shows car conditions. So the buy price, maintenance costs, number of doors, number of person, luggage boot, safety, etc. And using these 6 features, we have to predict the decision whether the car is unacceptable condition, it is an acceptable condition, and so on and so forth. So this is a multi-class classification problem. First, what we'll do is we'll divide the dataset into features and label set. So you can see here for features, we are removing this column and we will have these 6 columns, and for label, we are choosing the decision column. So press Shift and Enter here. Next, an important concept here is that since in these 6 features, 4 of them, you can see this, and these are categorical columns, but deep learning models, they work with numerical columns. So we have to convert these categorical columns to numerical columns. So one approach to do this is called one hot encoding. So you can, this script here, it first selects all the categorical columns in your data set and then apply one hot encoding on these categorical columns. So you could use pd.get dummies method and pass it your actual data frame, which is the feature set, and the list of categorical columns, and it will convert all your categorical columns to one hot encoded columns. So if you press shift and enter here, you can see that in place of your categorical columns, one hot encoded columns have been added. So for example, for buy price, it has added two columns, buy price low and buy price medium, buy price very high. And you can see, so here you could see the first row has had very high in the buy price column. So the buy price column has been replaced with three columns, and in the buy price very high column you can see one here. So basically we have converted our categorical columns to one hot encoded columns. So this is the step which you will do for both categorical cross entropy and sparse categorical cross entropy. Now we will first see the categorical cross entropy, how we apply categorical cross entropy on this code, on this data. So as I said earlier, for categorical cross entropy, your output labels should be one hot encoded. So just as we converted these categorical columns to one hot encoded columns, we will convert our label to one hot encoded column as well. So you can do this with this concept, this code here. I will just remove this here. So, pardon me, I think it's not ready. Okay, so I would like to show you the output as well. So here, so you can see that now your output is one hot encoded. We have four classes in the output, and each of these four classes have been converted into one hot encoded vectors. So we have four columns for four classes. So in this case, as I said, we will use categorical cross entropy. So I will first divide the dataset into training and test set. And next I will create my deep learning model. So this is a very simple model. It has an input layer. The number of features in the input layer will be, you can get the number of features using this code. So if I print it separately, you can see here we have 15 columns in our feature set. So the shape of the input will be 15 here. And I add two dense layers, the first dense layer with 64 nodes, the second dense layer with 32 nodes. So this is, I'm using Keras functional API, by the way. This is, the syntax is functional API. So we have input layer, two dense layer, and an output layer, which has softmax activation, because in case of multi-class classification, you will use softmax function. And finally, we create a model, pass it our inputs and outputs. So then we compile the model. So here, this is important. So here you can see the loss function we are using is categorical cross entropy. So in case of categorical cross entropy in Keras, you will pass this string, and this method will return us the model. So press shift and enter, and finally we'll start training our model for 50 epochs. We are predicting the car condition, these four labels, using the 15 features. And one important thing here is that here we'll have four nodes, because we have four outputs here. So since we have four outputs, four columns, you will pass 4 here, and if you print this value, you will see that it's equal to 4. So the number of classes should be the number of nodes in the output layer here. I don't know what's the mistake I have made. Just 1 minute. Shift and enter. Okay, it works. So I'm training my model for 50 epochs, and 20% of the data from the training set will be used as validation set. So press shift and enter here. The model will start training. So after 50 epochs, we get a training accuracy of 100%, which is obvious because our model is too complex, and our validation accuracy is 98.19. So let's test, let's plot the loss and accuracy for the model. So you can see this is our accuracy curve and this is our loss curve. Our model is slightly overfitting because here I have less training, less training loss as compared to validation loss. So I will link in the description my tutorial where I show you how to reduce overfitting in your deep learning model. But now we will make predictions on the test set. This is important concept as well. So your predictions will be in this form since we have 4 nodes. So for each record you will see 4 outputs, and each item in each output will be a value between 0 and 1 because we used sorry, not 0 and 1. So these 4 values will sum to 1. The sum of these 4 values will be 1, and each value corresponds to the probability of the class. So the first row shows that the probability that this belongs to class 1, which if we go here and see acceptable is 0. I think 0.000745 because it's in scientific notation, but it's very less. And this first row, the probability of it belonging to the third class is 0.999. So this will be converted to 1, and this. So what we want to do is to compare it to our actual output labels, which are one-hot encoded vectors. We need to convert these predictions into binary values. So you can do this. This basically says that for each row, give me the index of for which the probability is the highest. So in the first row, the highest probability will be 0, 1, 2 for the second index, and similarly for the second row, the highest probability is for the 0th index. So this is how it will convert these probabilities into 0s and 1, because only then we can compare it with the one-hot encoded labels. So if we press this, so you can see now these two are converted to 0 and this is converted to 1, and for the second row this is converted to 1 and the remainings are converted to 0. So now you can see that the shape of our prediction is one-hot encoded. It is similar to what we had here. So now we can simply compare them and we will evaluate the performance of our model. So I press this script and you can see that on test set we get an accuracy of 97.97%. So this is how you can use sparse categorical cross entropy in TensorFlow Keras. Now I will show you how to use sorry, this was for the categorical cross entropy, and now I will show you the code for the sparse categorical cross entropy. So I add a section to my Google Colab, and okay, as I said, the difference was between the output labels. So in this case we will convert our output labels to integers ranging from 0 to 1. So this code will do that. You can use label encoder from sklearn library. So now our output labels look like this, the output target labels, and I will, you can see here, yeah, so you can see this is how our output labels will look. So if you want to see which label belongs to which class, you can use this code here. I'll press shift and enter. You could see, okay, 0 is for acceptable, 1 is for good, 2 is for unacceptable, and 3 is for very good. We will again divide our dataset into training and test set. This is for sparse categorical cross entropy, and our model will remain pretty much the same here. And again, so everything is same here. There is one difference. Now the number of nodes here will also be equal to the number of unique classes. So you can get the number of unique classes using this code. So if you copy and paste here, you will see that we have 4 unique classes. So in case of one-hot encoded vectors, you could use this code to get the number of classes, and in case of integer labels, you could use this code here. The rest of the things remain the same. The code is very similar. So you can again train the model for the sparse categorical cross entropy here. tuple index out of range. This is interesting. Okay, so probably I did not compile this code. So shift and enter here and press shift and enter again here. Okay, so now the model has started training. You could see here. So after 50 epochs, again we get training accuracy of 100% and validation accuracy of 97.83. We can plot the training and loss curves for training and validation sets. You could see here. So they look very similar to what we got in case of categorical cross entropy. So in terms of performance, there is no difference. At least I didn't find any difference between categorical and sparse categorical cross entropy. So these curves, both of these curves, they look very similar to these curves here, if you see, and both of them are overfitting. And let's see what we get on the test set, the performance. Okay, so here one thing again. So our predictions will again be in the same format. We have 4 nodes in the output, and these nodes, the values of these nodes sum to 1, where the probability of the predicted class will be the highest. But one thing which you have to do here is in case of categorical cross entropy, we converted them into one hot encoded vectors because our target variables were one hot encoded. In this case, our target variables in case of sparse categorical cross entropy are integers. So we do not have to convert them into one hot encoded vectors. Rather, what we will do is we will for each record we will pick the index of the node with the highest probability. So for the first, here you could see we have the highest probability at the second index. So in the output we'll get 2. In here we have the highest probability for the this is a little tricky here, 27, 34, 38, probably for the first one, yes, 0.38. The highest probability is for the first one, so we'll get 1 here. So but in case of categorical cross entropy, we this becomes 1 and the remaining becomes 0. So that was 1 hot encoded. So this code will get you the index of the highest probability node. So you could see 2 for this, 1 for this, 0 for this, and so on. So since our target variables were also in the form of these integer labels, we can easily compare them using this code. And you could see the performance. So in this case, we get accuracy of 97.37%, 39% on the test set, and in the case of categorical cross entropy, we got 97.97%, which is pretty negligible. The difference is not significant. So what I have found working with categorical and sparse categorical cross entropy is there's not much difference in the performance. One thing at which I suggest is that if you have less number of classes, you should use categorical cross entropy. So if you have less number of classes, simply use one hot encoded, convert those classes into one hot encoded vectors and use categorical cross entropy. In case you have a large number of classes, then convert those classes into integer labels and apply sparse categorical cross entropy. One more thing which is important is that if your output labels do not have any order between them, then it is advisable to use categorical cross entropy, sparse categorical cross entropy with one hot encoded vectors. Sorry, I'm messing it up. So if there is no order in your data set, use sparse categorical cross entropy, one hot encoded vectors. If you have some order in your output labels, use sparse categorical cross entropy with integer labels. So this is how you can differentiate between categorical and sparse categorical cross entropy. I hope you like the video. If you have any question, you can put it in the comments. Thank you so much for watching.